Welcome back to the deep dive. This is where we really plunge into a stack of sources, pull out those key insights, and give you that shortcut to being truly well-informed. Today, we're not just dipping our toes in. Oh no, we're diving headfirst into a topic that's, well, it's profoundly reshaping our world. Artificial intelligence. It's not really some futuristic idea anymore, is it? AI it's kind of an intrinsic part of our daily lives now. It influences everything from, the shows you stream to the tools we use at work. And crucially for today, it's transforming how we learn, how we teach, maybe even how we think about human potential. It's accelerating impact across societies, organizations. It just makes this deep dive incredibly relevant for everyone.
Oh, absolutely. It really does. And this whole integration of AI, what people often call AAED, right, in the education world, it's much more than just a tech upgrade. It kind of demands a fundamental reevaluation of how knowledge is acquired, how it's shared. The implications for developing, human potential are just immense. It needs careful thought, foresight.
And to guide us through this complex, really fascinating landscape, our main source today is this multidisciplinary book. It's called AI in Learning, Designing the Future, edited by Hanlin Niemi, Roy D.P., and Yu Liu. What really strikes me, though, is it's not just a couple of opinions. It's this huge collaborative effort. I mean, over 60 researchers from top universities in China, the USA, Finland. That kind of global perspective, well, it's invaluable, isn't it?
Yeah.
Especially for AI in education.
Absolutely. The sheer breadth of expertise packed into this text gives you such a comprehensive view. It touches on everything, really, from the cutting-edge applications all the way through to the tricky societal and ethical stuff. It's a foundational resource, honestly, for anyone trying to get a handle on where AI and learning is now and, where it's headed.
Right. So our mission today, then, is basically to be your personal shortcut. We're going to distill the most important bits, those nuggets of knowledge, maybe some surprising insights from this really big work. Our goal is to help you understand exactly how these AI-based tools, these environments, are set to augment and genuinely support human learning. Not just automate what we already do, but really support it. And just as critically, we need to grapple with the ethical side, the dilemmas, the tricky questions that are popping up as human and machine learning kind of collide. We'll find those aha moments for you and hopefully deliver it all with just enough humor to keep you hooked. So yeah, let's get started. Okay, so to kick this deep dive off, the editors of AI and Learning, Designing the Future, they frame their whole exploration around two really fundamental questions. The first one is basically this: how is learning fundamentally changing when human learning and machine learning get connected? And what are the consequences? For education, obviously, but also for lifelong learning. In our working lives, it's all about that synergy, that intersection, isn't it? How does the very nature of learning shift?
That's really the core intellectual puzzle driving the book. And the second big question, maybe even more pressing for society right now, is what ethical issues are popping up with AI in education, specifically from the viewpoints of schools, other learning environments? These aren't just, abstract academic thoughts. They're practical, urgent things we need to pay attention to now. They really guide our understanding of AI's huge potential, but also the big responsibilities that come with weaving it into how we educate. It's basically saying, look, we can build powerful tools, but we have to understand the profound effect they have.
So the big aim here isn't just about making education, faster or more efficient by automating stuff we already do. It sounds much more ambitious. It's about figuring out how these AI tools can genuinely augment, genuinely support human learning. Push us beyond where we are now. The authors are, as they say, leaping forward to share the ways AI may contribute to redesigning our future by using it right there in education and learning. Could you give me a more concrete sense of what that redesigning actually looks like? How does AI augment in a way that's different from just automating?
Right. So when we talk about augmenting human potential, think way beyond just, AI grading essays faster. That's useful automation, sure. But imagine an AI providing a student with a truly personalized learning path, one that adapts in real time. It's not just ticking off tasks. It might sense when a student's confused or notice they're suddenly really engaged and then subtly shift the content or the difficulty to match that sweet spot, that optimal learning zone.
Okay, so it's reading the student in a way.
Exactly. Or think about an AI offering teachers incredibly detailed insights into student behavior patterns, maybe data points on engagement or collaboration, or even signs of stress, things a single human teacher just couldn't possibly track for a whole classroom. This then frees up the teacher to focus on the really human stuff, right? building relationships, fostering creativity, guiding critical thinking, handling complex social dynamics, while the AI handles the heavy lifting on the data analysis. It's a fundamental rethink of how we structure learning, moving beyond that traditional, often quite rigid classroom model towards something much more fluid, more responsive.
That's a really powerful vision, and it definitely sounds like something needing a global effort. The book points out this isn't just some niche academic thing. There's a real global push and a serious need for foresight in this whole AI and education field, AAD.
Oh, completely. A really significant step in that global collaboration was the OECD launching its AI Policy Observatory back in 2020. That's the Organization for Economic Cooperation and Development. And this observatory, it isn't just theoretical. Its main job is to actively track policy areas where AI is driving big, often disruptive changes. Think critical sectors like the workforce, transportation, healthcare. It also carefully monitors emerging AI trends and, importantly, how AI data is being used across different areas.
Okay, so it's about seeing the ripples, not just the splash, understanding the wider impact.
Precisely. The OECD set it up as this comprehensive global forum. It brings together everyone, governments, businesses, academics, civil society groups. The big goal is helping countries not just encourage AI development, but also nurture and responsibly monitor trustworthy AI systems, systems that genuinely benefit society. This commitment goes way beyond just tech advancement. It's about making sure deployment is ethical, it's equitable.
And part of that responsible development seems to be investing smartly. I saw the OECD AI principles specifically suggest combining investments for research, and crucially, they stress interdisciplinary efforts. Why is that interdisciplinary bit so key for AE?
It's absolutely vital because AI in education is what you might call a wicked problem. It's not purely technical. A computer scientist alone can't solve it. It's this complex intersection of computer science, yes, but also cognitive psychology, educational theory, sociology, neuroscience, ethics, all of it.
Right, you need all those different brains looking at it.
Exactly. You simply can't develop effective, fair, responsible AI for learning without bringing experts from all those fields together. The OECD principles highlight that future breakthroughs need to tackle tough technical issues, sure, but also, very critically, they have to fully engage with the social, the legal, the deep ethical implications AI brings. This kind of forward-thinking approach is crucial for shaping policy. We need to make sure we don't just build incredibly powerful tools, but build them thoughtfully, anticipating and mitigating the wider impacts before they get locked in.
So where are we right now, then? The book says AI is already massively applied globally, and in education, lots of advanced techniques exist with, quote, tentatively promising findings. Yeah, that phrase, tentatively promising, really jumps out. What does that tentatively signal about the current state? What are the big hurdles to getting past that?
Tentatively promising basically means that while we've got loads of exciting prototypes, pilot projects, initial studies showing positive effects in specific situations, the long-term, large-scale proof isn't quite there yet. We've seen enough to be genuinely optimistic about AI's potential in education, for sure, but we don't yet have enough solid evidence to make sweeping claims about it working everywhere, for everyone, or to roll these things out widely without more rigorous testing. The core challenge is just the breakneck speed of tech development. AI capabilities are evolving so fast. There's this constant, urgent need for extensive new research into how these technologies actually get implemented in schools, and, most importantly, what their long-term effects really are on human learning, on people's lives. It's a super dynamic, fast-moving field. Yesterday's big innovation can quickly become today's normal.
And as AI gets woven more tightly into our learning lives, those critical thoughts on ethical use become even more central, don't they? It sounds like it's not an add-on, but foundational.
Absolutely foundational. The more AI gets applied in education, the more vital it becomes to really deeply reflect on and build solid grounds for its ethical use. As Hanel and Niemi put it back in 2021, while AI in learning has this immense potential to transform education for the better, it also comes with significant limits, real worries. These are especially tied to critical ethical issues like inherent algorithmic biases, profound privacy concerns, the non-negotiable need for transparency in how AI actually works, and fundamental questions about who owns the data. This ethical dimension, it can't be a checkbox at the end of a project. It has to be an integral guiding principle right from the start, from conception and design, all the way through deployment and ongoing monitoring of any AI education system. Without that deep ethical commitment, we risk accidentally creating powerful systems that, despite being technologically clever, could actually worsen existing educational inequalities, or even create entirely new kinds of unfairness and harm.
Okay, we've sketched out the grand vision for AI in education, how it aims to augment human potential globally. Now let's zoom right in. Let's see how this vision translates into making learning genuinely personal, truly tailored for each person. And the book kicks this section off with a really fascinating idea that pushes AI beyond its usual limits: artificial curiosity. Expert speaker, the source material, referencing Nick Haber's work, talks about a critical gap between past AI successes and human learning. What exactly was that gap? What limits did it show?
Yeah, this is really insightful. It's about understanding the fundamental difference in how most successful AI systems historically learned compared to humans, especially kids. Take computer vision, for example. Those breakthroughs where systems identify objects or faces with amazing accuracy, their success depended heavily on what's called supervision. What that means practically is humans had to painstakingly curate and label massive data sets. I mean, tens of thousands, sometimes millions of images where every single object, every feature was meticulously tagged. It's a colossal human effort just to prep the data.
Right, like feeding it perfect examples.
Exactly. Now, contrast that with a human child. A toddler playing with blocks isn't getting constantly fed labeled data sets by an adult saying, this is a cube, this is red. They learn about shapes, textures, gravity, cause and effect, largely through, well, unsupervised exploratory play, driven by this intrinsic desire to just interact with their world.
So it's like the computer learns by being spoon-fed perfect categories, while the child just messes around and figures things out.
Precisely. And that leads straight to the second limitation, the difference between passive and interactive learning. Many successful AI systems were trained passively on these preset static datasets. They didn't make decisions about what to learn next or how to actively go find your information. They just processed what they were given. That's fundamentally unlike us humans. We're active learners, constantly deciding what to focus on, what to explore, what questions to ask. Even reinforcement learning, the stuff that got really good at Atari games, that introduced interactivity the agent learned by trial and error in its environment. But even then, success often relied on carefully crafted reward functions, basically explicit instructions from humans on what was good or bad behavior in the game. So while it was interactive, it still wasn't truly self-directed in its core learning motivations.
That paints a picture of a very narrow, purpose-built kind of intelligence. So if we want AI to learn more like humans, what are the 3 key traits Haber suggests it needs?
Haber proposes 3 crucial properties for AI systems to get closer to human-like learning. First, they need to learn flexible representations. The knowledge they gain shouldn't just work for the one specific task they trained on. It needs to be adaptable, useful across a whole range of different tasks and situations.
Okay, more general purpose.
Right. Second, they must learn through genuine interaction with their environments and, importantly, with others in those environments, much like kids learn through physical play and social interaction. And third, perhaps the most profound point, they should learn in a more self-supervised manner. This means relying on generic, flexible motivations like curiosity rather than needing strong, explicit supervision or predefined rewards. It's about developing internal drives to explore and learn, not just reacting to external carrots and sticks.
That idea of self-supervised learning, driven by internal motivation, sounds incredibly powerful. And that leads us to the cookie in a room analogy Haber uses.
Yeah.
How does that thought experiment really show the power of curiosity for AI?
It's a brilliant, simple example that makes it crystal clear. Imagine an AI agent in a room. In the room, there's a button. Pressing the button opens a door to a second room. And inside that room, there's a cookie, the ultimate goal. Now, if you have an unmotivated, non-curious AI agent with no explicit reward function telling it to go find the button or go through the door, finding that cookie would be an immense struggle, almost impossible. Its behavior would be basically random. It would have to, just by pure chance, stumble upon the button, push it, then randomly wander through the now open door, navigate to the cookie, and somehow eat it. Only then would it get an external reward. This would take an unbelievably long time, pure luck.
Like trying to find a needle in a haystack, but you don't even know what a needle is or why you're looking.
Exactly that. Now contrast that with a curiosity-driven system. This AI isn't just waiting for an explicit reward. It has an internal drive, an intrinsic motivation to explore the unknown, to figure out what happens when it interacts with new things in its environment. It's curious about what the button does, what's behind that door. This system actively explores, quickly learns how the room works, and almost inevitably and much, much faster achieves its goal of finding the cookie. Haber points out this kind of curiosity-based learning moves us a step closer to the sort of learning we see in human development. Kids, right? They don't need explicit instructions or rewards to explore. Their world is just inherently interesting, inherently novel, and they learn by engaging with it.
So it's about making the AI more like a kid in a sandbox, driven by that internal spark of discovery. How does this actually get tested? The source mentions a playroom experiment.
Yeah, the Playroom experiment from Haber and his team in 2018 is a simplified but really powerful demonstration. They made this 3D virtual environment. An AI agent could move around a room and interact with simple toys, just basic blocks. The agent had a limited view and could push or twist objects it saw nearby. Through this seemingly basic interaction, these artificial systems learned fundamental sensory and physical representations of their world. They started to grasp things like solidity, weight, how objects move when you push them. What's even more remarkable, they showed they could learn representations of others, meaning they started forming basic understandings of how other agents might interact with these same toys. That's a huge foundational step towards developing more sophisticated social intelligence in AI, letting them anticipate and understand what others might do in a shared space.
This is a truly mind-bending idea. AI systems not just learning about the world, but becoming predictive models of human learning itself. How does that work? It sounds almost reciprocal.
This is where the really profound insight comes in. The idea is, by engineering AI agent architectures that can accurately mirror human behaviors and abilities, we can, in turn, generate predictive models of how we humans learn. It's this powerful feedback loop. The task-driven modeling hypothesis, which Yemins and colleagues proposed back in 2014, suggests that if we can build AI systems with the right sorts of capacities and behaviors, meaning if they learn and interact in ways that closely mimic human learning, then the internal workings, the algorithms, the neural architecture of that AI system could potentially give us incredibly deep insights into how human cognition and development actually work.
So if we can build an AI that genuinely learns like a human, it can effectively teach us about ourselves, about how we learn best.
Precisely. And that has transformative implications for education. Imagine being able to understand at a really granular level what specific environments or teaching strategies or even emotional states lead to particular learning outcomes in people. If an AI model can accurately predict human learning paths under certain conditions, it gives educators and curriculum designers incredibly powerful data-driven tools. It flips the problem from just trying to teach AI to learning from AI about how humans learn most effectively. It's an engineering challenge aimed at understanding the very essence of human intelligence and then using that knowledge to design better, more empathetic learning environments for all of us.
Okay, moving from cognitive curiosity to another critical, often overlooked area for truly personalized learning, nurturing a student's emotional well-being. The book talks about how AI can be used for holistic student development, specifically in assessing and tracking student well-being. Why is student well-being considered so critical in the first place, according to Xin Tang and her colleagues?
Right. Xin Tang and her co-authors really stress that student well-being is absolutely paramount. It profoundly influences not only their immediate positive development in school, but also, just as importantly, ensures their future growth and overall success in life. If you neglect a student's emotional and psychological state, it can have these cascading negative effects on everything from their grades to their social life, even their long-term mental health. It's really the foundation that all other learning is built on.
In traditional ways of assessing well-being, it sounds like they're not really up to scratch for real-time help. They're often too slow.
That's exactly it. The source points out that traditional well-being assessments have usually been static and lagging behind when it comes to providing timely diagnosis and intervention. Think about a typical survey given once a semester, maybe once a month. By the time you collect the data, analyze it, share it, the student's emotional state or specific challenges might have completely changed. This kind of rearview mirror approach really limits your ability to give prompt, relevant, effective support right when it's needed most. It's like trying to steer a ship by looking at where it was an hour ago.
So this is where AI comes in with a newer, much more dynamic solution. Tell us about the school day well-being model.
The school day well-being model is presented as this innovative AI-based automated scoring system. It's specifically designed to get past those traditional limits. Its key features are that it's both dynamic and operates in real time. This means it can capture the fluctuating moment-to-moment nature of a student's emotional and psychological state. It gives a much more immediate, nuanced picture than static methods ever could. The core goal isn't just to measure well-being, but also to simultaneously help improve it by giving timely feedback and support.
How does it manage to be dynamic in real time? What's different about its data collection?
What's really innovative is its unique approach to data collection, which cleverly combines assessment with the potential for immediate improvement. It uses something called experience sampling methods. Instead of one long, often tedious questionnaire, the system gives short, targeted survey items at different times, often randomized throughout the school day. But here's the crucial AI bit. These random measurements are specifically driven by AI techniques that strategically and automatically select the questions to ask. This intelligent selection makes sure the data collected is highly relevant and targeted to the student's current situation, optimizing the diagnosis for maximum efficiency and insight.
So the AI is smart enough to figure out which questions to ask and when to get the best real-time snapshot of a student's well-being, almost like a really insightful friend checking in.
Exactly. This lets the system gather really relevant information much more efficiently and less intrusively. And the payoff is big. After this targeted data is collected, the student's well-being status is reported automatically. And crucially, feedback for improvement is delivered timely. This creates a real-time feedback loop, allowing for quick interventions and support. What's particularly promising, and suggests it could work widely, is the finding that the results from this model were consistent across the globe. That suggests this AI-driven approach to well-being could be used effectively in very different educational contexts worldwide, offering a consistent, reliable measure.
That's a powerful tool for student well-being. Now, shifting gears slightly, let's talk about how AI can help guide futures, especially around career knowledge and planning. It's no secret young adults today face a lot of ambiguity and insecurity in the job market. They often lack informed choices or those informal networks that are so important for career planning. Sounds like a big pain point.
Oh, it absolutely is. Ai-Chin Chen and her colleagues highlight this as a major challenge. Those traditional, clear paths to careers that maybe existed before, they're much fuzzier now. Many young people just don't have access to the mentorship, the family connections, the professional networks that historically help guide career choices. This can leave them feeling pretty lost, struggling to make huge decisions about their education and future career in a world that's changing so fast. It's a real equity issue too, you know?
So what's the theoretical idea they're using to tackle this? The source mentioned something called alignment theory.
Yes, the theoretical backbone for their work is the theory of aligned ambitions, first proposed by Schneider and Stevenson back in 1999. This theory basically says a state of aligned ambitions happens when young people develop a clear, coherent understanding of three connected things. First, the kinds of jobs they genuinely want. Second, the specific education and training they actually need to get those jobs. And third, realistic ideas about the salary they can expect in those careers. The core idea is, when students have this integrated, realistic, self-aware understanding, they're much more likely to create a strategic plan that actually aligns their educational hopes with their future career goals. It's about closing that often huge gap between dreaming and doing through informed knowledge.
And how are they actually using AI with this theory? The Init game sounds like a pretty interesting approach.
Init is described as a game simulation. It's designed not just for young adults figuring out their first careers, but also for people who might have lost jobs and are looking for new paths. What makes it powerful is how it seamlessly blends data-based analytics with occupational information algorithms. This isn't just a simple quiz or a static career guide. It's a dynamic, interactive platform. Users actively make choices about education planning, salary expectations. And as they do, the game helps them visualize themselves in a dream job scenario. It offers this concrete, simulated experience of their potential future, letting them try out different paths virtually.
How does the machine learning part, especially decision trees, actually work inside Init to guide those choices and give that personalized insight?
Right, this is where the AI really shows its predictive power. Init, when it uses machine learning, specifically decision trees, to analyze a user's inputs and then predict the alignment or misalignment between their goals and the paths they're considering. Think of a decision tree like a complex flowchart. It starts with decision nodes, basically questions the system asks, either directly or by analyzing inputs. Questions like, what major do you want to pursue? Or what kind of college are you thinking about? Or what starting salary do you expect? Each answer leads down a different branch with more questions, eventually ending up at the leaves, which represent the predicted outcomes.
And those leaves are where the matched or mismatched predictions come in. So the game is kind of saying, based on these choices, here's how likely you are to hit your target.
Exactly. The system uses these decision trees to predict if a student's stated career goal lines up realistically with their college plans and salary hopes. For example, if a student says they really want to be a specialized engineer but then picks a liberal arts major with a low expected starting salary, the decision tree might flag that as a mismatched outcome. It's not a judgment, more like a data-driven nudge for the user to maybe reconsider their choices or explore other more aligned paths. It's a powerful way to provide foresight and guide them towards more informed decisions.
What are the main strengths and maybe future plans for Any to Win It? It sounds like it could even work well with incomplete data, which is a real-world problem.
Yeah, one of its key strengths, according to the authors, is its simplicity and effectiveness. The design is straightforward enough to really boost students' alignment between their dreams and the realistic ways to achieve them. And it's surprisingly good at predicting educational expectations. Crucially, it's useful even where background data is not available or where there is over 10% of missing data. That's a very common issue in real educational data sets, so that makes it robust. Looking ahead, the author suggests machine learning could be integrated even further into the game, maybe to measure students' strengths and weaknesses more directly, perhaps through game challenges. This could lead to even more nuanced, personalized career recommendations. It could really serve as a vital informational channel for students who lack informal networks, helping to level the playing field for career guidance that used to rely so much on personal connections.
That's a huge potential benefit for fairness in career advice. Now, let's switch focus from career planning to the actual materials students learn from. Expert speaker, tell us about the evolution here, moving from simple ebooks to something called intelligent textbooks. What makes them intelligent beyond just being digital?
Right. Bo Jiang and his co-authors really emphasize that intelligent textbooks are a significant leap beyond just regular digital ebooks. While ebooks offer basic stuff like highlighting and note-taking, intelligent textbooks embed sophisticated, intelligent tutoring technologies to provide what they call intelligent reading support. The crucial difference is they don't just passively record what you do, they actively attempt to understand why readers interact with the textbooks. This understanding then lets them build scaffoldings to enhance reading experiences in a personalized, adaptive way.
So they're not just passive content, they're actively trying to figure out the reader's thought process and adapt. That's a big shift.
Exactly. Imagine highlighting a sentence in a normal ebook, nothing happens, right? But in an intelligent textbook, like the Inquire Biology example they mention, highlighting a sentence might prompt the textbook to actively ask you a follow-up question. Encourage deeper thinking about why you highlighted it or what you found interesting. Or if you were to type a question into the textbook, it could respond intelligently using its own reasoning, much like a human tutor might, giving explanations or guiding you to relevant bits. This moves learning beyond just finding information or recalling facts, fostering real comprehension and critical engagement with the material.
And what's the core intelligence mechanism behind this? It sounds like it borrows heavily from intelligent tutoring systems, IS, which I know is a well-established field.
That's right. The intelligence inside these textbooks comes directly from the Foundational Intelligent Tutoring System, ITS model. This model is formalized by three key interconnected components working together to provide adaptive learning. First, there's domain modeling. This is basically the textbook's knowledge base and ontology. Think of it as the textbook's deep understanding of the subject. It stores a huge amount of subject-specific knowledge, organized taxonomies, examples, exercises. A critical ongoing effort here is to develop automated modeling technologies and automatic knowledge annotation. The goal is to dramatically reduce the incredibly time-consuming, expensive manual process of building this knowledge base. Automating this helps provide high-quality labeled data for the machine learning algorithms, making these systems much easier and cheaper to build.
Okay, so that's the what it knows. What's next?
Second, and this is the really personalized core, is student modeling. This component's main job is to understand students' learning using their interaction data. A completed student model is incredibly comprehensive. It holds insights into the student's current knowledge state on different topics, their typical behavior patterns interacting with the textbook, their learning emotional state, are they confused, engaged, frustrated, bored, and even domain-independent traits like their cognitive ability, their preferred learning style, motivation levels, their overall attitude to the subject. This highly detailed, dynamic model is what drives the learning system to adapt to the needs and knowledge of students, letting it provide truly personalized support and interventions in real time.
Wow, that's incredibly detailed. And the third part?
And finally, there are the instructional technologies. This component specifies the policy, the rules for administering automated instructional actions. Based on the rich insights from the student model and the vast knowledge in the domain model, this is where the system decides what kind of help or intervention to provide, when is the best time to provide it, and how it should be delivered to really maximize the student's learning.
That sounds incredibly comprehensive, much more than just a digital book. So does all this intelligence actually work? Does it show results in real schools?
According to the authors, yes, absolutely. Many empirical studies in schools have consistently demonstrated the effectiveness of intelligent textbooks in facilitating students' reading and learning. This indicates really promising prospects for this technology. The ability to understand the learner's journey at such a detailed, real-time level and then adapt the teaching accordingly has shown clear, measurable benefits. It improves comprehension, engagement, and overall learning outcomes compared to traditional static materials. It's a significant step towards truly adaptive, responsive educational content that can meet students where they are, exactly when they need it.
So we've looked at how AI can tailor learning directly for students. Now let's shift focus to empowering, well, the unsung heroes of education, our teachers. They face so many challenges, and one that often doesn't get enough systematic attention is handling student problem behaviors. Things like internet addiction, maybe school bullying, social anxiety. Teachers often lack specific, easy-to-access experience in identifying and diagnosing these complex things, mainly because the research is kind of scattered, hard to find quickly. Sounds like a big resource gap for educators on the front line.
Oh, it absolutely is a critical challenge. Peng Chen and Yu Lu highlight this really well. While teachers are experts in their subjects, highly skilled at teaching, the nuanced work of identifying, understanding, diagnosing complex student behaviors like addiction, bullying, severe emotional distress, that requires highly specialized knowledge. It's not always part of standard teacher training, and because the relevant psychological, sociological research is so fragmented, they often don't have a systematic go-to resource for guidance. This can leave them feeling unprepared, maybe overwhelmed, in situations that deeply affect not just the student's well-being, but the whole classroom environment.
So their proposed solution is an AI-powered assistant. How does this assistant use what they call task-oriented dialogue system technology to help teachers diagnose these problem behaviors? What's its main goal?
The solution they propose is indeed an AI-powered assistant, specifically designed to bridge that knowledge and support gap for teachers. It uses task-oriented dialogue system technology that's a sophisticated type of AI designed to interact with users in natural language, kind of like a really smart chatbot, but with a specific goal: helping diagnose student problem behaviors. The main goal is to dramatically improve the accessibility of diagnostic services for teachers. Instead of having to wade through academic papers, wait for specialist appointments, or just rely on intuition, a teacher could have a real-time, guided, interactive conversation with the AI assistant to systematically gather info, explore potential diagnoses, and get initial insights.
This sounds like it needs a really solid, multifaceted theoretical foundation to make sure the diagnoses are sound, holistic. What's the bedrock guiding this system's design?
It's built on an impressive, really comprehensive theoretical framework. It integrates multiple psychological and sociological perspectives to get a holistic view of student behavior. First, it uses the concept of need deficiency, adapting Maslow's famous hierarchy of needs from, 1943. The system works on the idea that problem behaviors often stem from unmet psychological needs. For K-12 students, they cleverly adapt Maslow's original 5 levels. They keep physiological, safety, belongingness, love, and esteem needs, but they replace self-realization with cognitive need. The AI tries to systematically figure out which of these core needs aren't being met for a student, seeing that unmet need as the root cause driving the behavior.
Okay, so looking for the unmet need behind the behavior.
Exactly. Second, the system uses a sophisticated problem behavior classification. This is inspired by the well-known Achenbach and Rescorla's Child Behavior Checklist, CBCL, but it's thoughtfully modified based on analyzing lots of real-life cases. It sorts behaviors into 3 main, fairly intuitive types. 1. Externalization problems. These are behaviors directed outward, often signs of social adaptation issues. Think aggressive behavior, bullying, fighting, or rule-breaking behavior like defiance or property damage. 2. Internalization problems. These are behaviors directed inward, signaling emotional distress. This includes things like social withdrawal, depression symptoms, anxiety. And 3, other problems. This is a kind of catch-all for things that don't fit neatly into the first 2, like specific learning problems, egocentricity, or other unique challenges.
Is it really looking beyond just what the student is doing to try and understand why, and then sorting those behaviors into meaningful groups?
Precisely. But it doesn't stop there. Beyond the internal needs and the observed behaviors, the framework also meticulously considers external environmental factors that profoundly influence behavior. These are broken down into 3 critical areas. First, family factors. This is really comprehensive. It includes family structure, single parent, two parent,
Hmm?
parenting style,
Yeah.
permissive, parents' education, health conditions in the family, any history of delinquent behavior, and the family's overall socioeconomic status. All these can significantly impact a child.
Makes sense. What else?
Second, school factors. Here, the system looks at things specific to the school environment, like the teacher's leadership style, how accepted the student feels by peers, the broader peer influence in their social circles at school. Third, society factors. Drawing on social learning ideas, this category considers wider societal influences, especially the impact of social media and prevailing cultural norms that shape how adolescents behave.
Okay, family, school, society. What about the individual student?
And finally, the system comprehensively accounts for individual factors, the unique physical and psychological traits of the student themselves. This includes basic demographics like grade level, gender, general health, social group affiliations. Crucially, it also incorporates personality, using the widely recognized Big Five traits: neuroticism or emotional stability, extroversion, openness to experience, agreeableness, and conscientiousness. This incredibly detailed, multi-layered approach ensures the AI's diagnostic process is holistic, considering all relevant aspects of the student's life and context.
That's an astonishing level of detail for an automated system. How does this complex theory actually become a functional system a teacher interacts with?
Yeah.
You mentioned 3 main modules.
Yes, the AI teacher assistant is structured with 3 main modules working together: diagnosis, question answering, and case search. Let's break down the diagnosis module first. This is the absolute core. It's designed to conduct that systematic problem behavior diagnosis. It engages in a multi-turn dialogue with the teacher, asking smart, targeted questions to get all the necessary info about a specific student. For example, if a teacher initially says a student shows aggressive behaviors, the system won't just stop. It'll ask intelligent follow-ups. Can you describe a specific instance? Does this happen only with peers or adults too? What usually happens right before?
Okay, so it digs deeper.
Right. And this module itself has 4 highly sophisticated bits working behind the scenes. 1. Natural language understanding, NLU. This uses advanced AI to interpret the teacher's free-form replies, like, yes, he gets aggressive on the playground at recess, and pulls out the precise meaning, the key details, behavior type, context, triggers. 2. Dialogue state tracking, DST. As the conversation goes on, this component constantly updates a dialogue state, an internal record of everything gathered about the student so far. It keeps refining this based on the NLU, so the system always has the latest, most complete picture. 3. Dialogue policy learning. This is really the brain of the conversation. It uses sophisticated reinforcement learning. Think of an AI learning optimal strategies through trial and error, like a chess computer to decide the next best action. Has it got enough info to suggest an unmet need and offer advice? Or does it need to ask for more detail? This makes the conversation super adaptive, efficient, tailored to what the teacher is saying.
Very smart. And the last component.
4. Natural language generation, NLG. Finally, this takes the system's chosen action, like ask for more detail or present diagnosis, and turns it into a natural, human-like text response. This makes the dialogue flow smoothly, feel less like talking to a machine, more like consulting a knowledgeable expert.
So it's actively listening, updating its understanding in real time, and then intelligently deciding how to proceed, much like a seasoned human expert would in a consultation. That's incredibly powerful. What about the other modules you mentioned?
Right. The second module is the question answering module. Unlike the diagnosis module, which focuses on one specific student, this provides general guidelines on typical problem behaviors. A teacher, maybe prepping for a parent meeting, could ask a broad question like, what are typical problem behaviors for high school girls? What are common interventions? This module uses community question answering CQA technology. It's built on huge data sets of historical Q&A scraped from professional online forums, expert communities. It gives teachers quick access to validated, broad knowledge on various behavioral issues, like a ready-made expert knowledge base.
Useful for general background. And the third one, case search.
And the third module is the case search module. This one offers fine-grained guidelines and advice by smartly recruiting similar historical cases where specific problem behaviors were identified and interventions were tried. A teacher could input details about a student's current situation, and the system, using an advanced hierarchical BERT model. BERT's a powerful AI language model known for understanding context and similarity really well, would find comparable historical cases from its database. This gives teachers concrete examples of past successful strategies, their nuances, their outcomes. It offers practical, evidence-based support that's highly relevant to their specific situation.
So it's not just diagnosing, but providing practical, real-world advice and examples for teachers. That sounds like a true force multiplier for educators. Now let's talk about optimizing the classroom dynamic itself. The book critiques traditional methods of classroom teaching analysis. It says they're often content-free, low efficiency, and small scale, relying on tedious manual counting, coding behaviors. Seems like a massive bottleneck for real teacher development.
It absolutely is a huge limitation. Zhang Sun and his co-authors point this out meticulously. Traditional methods, like manual time coding, where someone sits in a class counting how often a teacher asks a question or a student raises a hand, they're inherently content-free. They don't capture the deep meaning or pedagogical quality of those interactions. They tell you how often the thing happens, but not why it matters or how effective it was. And being manual, they're obviously low efficiency and small scale. You can only analyze a few classrooms with a massive investment of time and resources. This makes it incredibly hard to give timely, actionable, widespread feedback for improving teaching quality across a whole school system or district.
So to get past these problems, they propose an AI-supported classroom teaching analysis framework called TESTI. What makes TESTI a human and AI technologies blended analysis framework? How does it aim to foster high-quality teaching?
TESTI is explicitly designed as this synergistic blend of human expertise and AI power. Its core idea isn't AI replacing human observation or insight, but augmenting it. The framework is built around Robert Gagne's well-known 9 major teaching events. This gives a systematic, comprehensive way to analyze the whole teaching process, from getting attention right through to giving feedback. The goal is to move beyond isolated behaviors to understand the compound structural system of teaching, get a more inclusive, systematic view of classroom analysis. This fusion aims to overcome those past limits and really foster high-quality teaching at scale.
Okay, let's walk through the 5 steps of TESTI. How does it start with identifying teaching events?
The first step, identifying teaching events, uses cutting-edge AI. It employs natural language processing, NLP, to analyze text like lesson plans or classroom transcripts, and computer vision, CV technologies, to analyze video recordings of classes. These AI models are trained to automatically spot various teaching events, like when a teacher is explaining something, asking a higher-order question, or giving specific feedback. This offers significant advantages in time and resource savings compared to the old way of manually watching and coding every single thing. However, and this is crucial, it operates in a unique human-machine cooperation mode. While AI rapidly spots patterns in initial events, human experts are still essential. They need to recognize the deep meaning of the word, accurately pinpoint subtle changing expressions of activity, and figure out the meaningful sequence in the teaching structure. The AI provides the raw, pre-analyzed data and initial tags, and then human experts refine it, add context, add that crucial layer of pedagogical insight.
So using AI for scale and speed, but keeping human expertise for the deeper understanding. Got it. What happens after events are identified? Step 2 is sequencing the pedagogies.
Right. Step 2 is sequencing the pedagogies. This is where the framework goes beyond just listing isolated events. Its aim is to structure the analysis to really understand the compound structural system of classroom teaching. How do different teaching events flow? How do they connect, build on each other to form a coherent, effective teaching strategy, rather than just being a random collection of actions? Think of it like understanding the rhythm, the choreography of a good lesson.
Makes sense. Then step 3, analyzing interaction.
Step 3 is analyzing teacher-student interaction using what they call multimodal recognition. Traditional analysis often just used one data source, like audio transcripts. TESTI, though, does multimodal recognition via visual and auditory fusion on behaviors and discourse. It analyzes not just what's said, but also student and teacher body language, facial expressions, gestures, other nonverbal cues. This hugely surpasses traditional single-source methods. To make it precise, time coding is adopted within the teaching phases composed of teaching events. This gives highly targeted evidence for analysis, offering a much richer, fuller picture of the dynamic interactions in the classroom.
That's truly granular, using multiple senses, so to speak. And then it moves from analysis to interpretation and, critically, to suggesting improvements.
Exactly. The fourth step, interpreting teaching meaning, focuses on drawing deeper insights from all that analyzed multimodal data. It's about connecting observable behaviors and interactions to the underlying teaching intention and, crucially, evaluating how effective they were. This moves beyond surface stuff to understand why certain approaches might work better or be problematic for learning goals. Finally, we get to the fifth and arguably most valuable step. Providing improvement strategies recommended using what they call the APSP method analysis problems strategies practice. Here, the specific classroom teaching features identified are classified into clear teaching problems. Maybe observations like a teacher-centered structure where students don't talk much, or signs of passive learning. These identified problems are then intelligently matched with a database of effective teaching strategies and cases. This database was collaboratively developed by the human AI system, combining research-backed pedagogy with real-world examples. This matching lets the system generate highly specific instruction and recommendation for teachers, empowering them to improve their teaching structure. It gives concrete, research-backed advice tailored precisely to the issues found, guiding educators to systematically refine their craft.
So AI can truly become a personalized teaching coach, helping educators refine their skills with precision and scale. That really makes AI a direct partner for teachers.
Absolutely. The conclusion here is crystal clear. AI has the potential to make powerful impacts on the whole future of teaching and learning. These impacts aren't just theoretical, they're reflected in the learning scene and the teaching process itself. AI for Learning, as Niami noted in 2021, offers many applications and multimodal channels for supporting people in cognitive and non-cognitive task domains. This moves AI way beyond just admin support. It deeply impacts the core act of teaching and the very experience of learning, transforming it into something more personal, insightful, and effective for everyone involved.
We've looked at AI tailoring knowledge and empowering teachers. Now let's jump into another exciting area, experiential AI, diving into how games, simulations, virtual reality are changing learning by making it immersive, active. We'll start with how AI can foster emotional resilience, self-regulation, especially in high-stakes, simulation-based learning. Expert speaker defines self-regulated learning, SRL, based on Zimmerman's 2008 definition. Why is this concept so key when learning in a simulation?
Right. What's foundational here is self-regulated learning, SRL. According to Zimmerman, SRL describes self-generated thoughts, feelings, and actions that are planned and cyclically adapted to the attainment of personal goal. This definition is crucial because it really emphasizes the learner's responsibility and autonomy in their own learning. In a simulation where a learner is actively engaged in a dynamic, often tough environment, their ability to set goals, monitor their own progress, adapt their strategies on the fly, manage their emotional responses, basically, to self-regulate, that directly impacts their success, the depth of their learning. It's about being an active strategic player in your own learning journey, not just passively receiving info.
And emotions, they're not just a side effect, are they? The source calls them learning modulators. That sounds much more active.
Exactly. Keely Ricamo and her team highlight that emotions aren't peripheral. They're deeply, intrinsically tangled up with learning. As Engstrom noted way back in '82 and Ting et al. Emphasized more recently in 2017, emotions strongly modulate learning outcomes and experiences. This means whether a learner feels positive things like excitement, engagement, or negative ones like frustration, anxiety, that can significantly impact how well they learn. It's not a simple positive is always good, negative always bad equation. Both can facilitate and hinder learning, depending on the learner's state of mind, as McConnell and Eva pointed out in 2012. For instance, a bit of managed frustration can actually drive deeper problem-solving, perseverance, but overwhelming anxiety. That can completely shut down thinking and block learning. Understanding that dynamic is key.
So how did they explore this in a practical, real-world place? The study on trainees at oil company Nest sounds like a great example.
Yeah, this is an excellent example of applied research in high-stakes learning. Rocamo et al. Studied basic training trainees at oil company Nest. They were learning in a sophisticated simulation-based learning environment, an SBLE. The findings were quite revealing. While the NPLE was generally seen as positive, effective for most learners, they frequently hit challenging situations, especially with complex chemical engineering processes, tricky operations. These tasks were often experienced as stressful, and emotional regulation was needed by the trainees to cope effectively and perform well. This highlights exactly where emotional self-regulation becomes not just helpful, but absolutely critical for learning and performance.
And what specific self-regulated learning strategies did these trainees identify and use to get through those stressful moments in the simulation?
The study carefully identified 4 key self-regulated learning (SRL) operations trainees consciously used to navigate those tough, stressful situations. 1. Metacognitive monitoring. This is the learner's awareness of their own thinking, their learning progress. A trainee might pause and realize, okay, I'm confused about this step in the procedure. I need to rethink or check the manual. It's that internal self-check.
Right, knowing what you don't know.
Exactly. 2. Social scaffolding. This means actively seeking and getting support and feedback from others, maybe an instructor watching or a peer working alongside them. They wouldn't hesitate to say, I'm stuck, can you give me a hint, or what would you do here? 3. Cognitive operations. These are the active problem-solving and info-processing strategies they used. Logically analyzing an alarm, methodically checking parameters, mentally running through different scenarios. One trainee vividly described it. They initially felt confused by something unexpected, but then consciously thought, okay, I need to increase the gas intake for the fire and increase the air level to keep it balanced. That shows active strategic thinking.
Yeah, thinking it through under pressure.
And 4, emotional regulation. This was crucial for managing the stress, the negative feelings in that high-pressure environment. Examples included mentally accepting a possible failure to lower anxiety, understanding realities of the complex situation to get perspective, or physically taking a time out to regroup. One particularly vivid story describes a trainee having a momentary blackout, feeling totally overwhelmed, couldn't think straight, needed to gather thoughts, even count how to justify myself that my decision was right before they could carry on effectively. This powerfully shows the direct, immediate impact of emotional state on thinking and performance under pressure.
That blackout story really brings the human element into focus. So given these insights into human self-regulation under stress, how could an AI tutor specifically step in to help learning in these simulation environments? Maybe going beyond what human help alone can do at scale.
The researchers identified 3 specific, impactful ways an AI tutor could significantly boost learning in SBLEs, tackling both thinking and feeling challenges. 1. Help for decision-making. In really complex situations with lots of interconnected factors, a human instructor might struggle to give real-time, full guidance without just giving the answer away. An AI tutor, though, could intelligently provide a list of choices, or even everything you need to consider to reach a specific goal. It wouldn't necessarily spell out the single right answer, but it would give all the necessary bits or potential actions, letting learners figure out the best order or strategy themselves. As one trainee suggested, you would know all the things you should do, but would need to figure out the order by yourself. Fosters independent problem solving while making sure they have the key info.
Okay, providing the pieces, not the whole puzzle.
Exactly. 2. Visualizing critical points. In a dense, realistic simulation, learners can easily get overwhelmed, miss crucial cues. An AI tutor could intelligently offer visual clues to help learners focus their attention on relevant things in the situation. For example, if a pump is subtly leaking, the AI could visually highlight it. Or if a critical dial on a complex control panel is creeping into the red zone, it could draw attention there. If a navigation route on a screen is unclear, the AI could show a clearer path. This directly helps with cognitive load, helping learners prioritize info, focus on what really matters in the moment.
Like a smart spotlight.
Right. And 3, asking questions. Instead of just giving info or direct instructions, an AI tutor could effectively prompt learners by asking questions that guide them to check vital points in the simulated system. This encourages active critical thinking, metacognitive monitoring, self-correction. For instance, what's the pressure reading on pump A? Or what might happen if you open valve B now? This nudges learners to develop their own problem-solving and diagnostic skills rather than passively getting instructions, fosters a deeper, more transferable understanding. These applications powerfully show how AI can support not just the cognitive, but also the emotional and metacognitive sides of learning in highly realistic, stressful situations, preparing people not just for tasks, but for the real pressures of their future jobs.
That's a powerful vision for AI supporting deep learning, especially in tough environments. Speaking of tough skills, let's talk about hard skills training in virtual reality, particularly for industry. Scalability is a huge issue here, right? This kind of training often needs expensive one-on-one human supervision. Sounds like there's a real push for computer systems letting learners learn by themselves, maybe even better.
That's absolutely right. Tina Korhonen and her colleagues really hammer home this urgent need for scalability in industrial hard skills training. Historically, learning complex practical skills like operating heavy machinery, doing intricate surgery, assembling precise parts demanded intensive, often one-on-one human supervision. This makes it incredibly resource-heavy, expensive, hard to scale across a big workforce, especially if people are spread out geographically. The drive now is towards creating computer systems that would allow learners to learn or assess their knowledge and skills by themselves, without needing a human trainer constantly looking over their shoulder. But just dropping a learner into a realistic VR world isn't enough. They still need personalized teaching guidance to get really effective learning and operational skill. Without it, it's just an expensive simulation, not really a learning tool.
And this is where intelligent tutoring systems, IDKs, come into VR. But the source suggests existing VR systems, while impressive, might not be achieving more meaningful learning. What's the difference between what's out there and what they're aiming for?
Existing VRs, like systems such as Steve or Pegasus, they definitely adapt to what the learner does. They often work through pre-programmed rules that trigger specific feedback or corrections based on changes in the virtual world. Like, if a learner does something wrong, the system might play a sound or highlight the error visually. While that's functional, useful for basic step-by-step training, this rule-based approach can be a bit rigid, limited. The goal with a more advanced AI tutor framework, as proposed, is to achieve more meaningful learning. Learning that isn't just about mechanically following steps, but about deep conceptual understanding, developing adaptive expertise, truly internalizing the skill so you can apply it in new situations. That needs a much more nuanced, sophisticated model of learner thinking than simple rule triggers can offer.
So what's their ambitious vision for this AI tutor? It sounds deeply rooted in something called 4E cognition. Can you break that down for us?
Yeah, their proposed AI tutor framework is indeed deeply grounded in these emerging cutting-edge theories of grounded cognition, specifically the 4E cognition perspective. The 4E is a powerful way to remember four key interconnected aspects of how thinking and learning happen. First, embodied. Learning happens not just abstractly in the mind, but profoundly through physical interaction with the world. Your body, your actions, your senses are integral to understanding.
So learning by doing, literally.
Right. Second, embedded. Learning is always situated within a specific, rich environment and context. It's not isolated, it's deeply tied to the setting where it happens. Third, enacted. Learning is an active, dynamic process. The learner actively constructs knowledge through doing, through performing actions, engaging with the with, active participation, not passive reception. And fourth, extended. This intriguing idea suggests that cognition actually extends beyond the brain. It incorporates external tools, technologies, even the environment itself as part of the thinking process. Like using a calculator for complex math, the calculator becomes part of your cognitive toolkit.
Okay, so mind, body, environment, tools, all connected.
Exactly. The framework assumes that the learner's cognitive state emerges from interactions between cognitive activity domains. It means understanding how the learner's physical body, the environment around them, any social interactions, all contribute dynamically to their learning, not just focusing solely on mental processes in isolation. It's a truly holistic, dynamic view of learning.
That's a very holistic, active view of how we learn. So based on this 4E idea, what are the key parts of this proposed VR-native AI tutor framework? How do they interact?
The framework carefully outlines distinct but connected components designed to work within an immersive virtual reality training environment, IVRTE. 1. Physical environment simulation. This is the basic VR immersive virtual environment, IVE itself. It creates the compelling illusion of a virtual physical space using sophisticated sensory simulators, mainly visual displays, but could also include haptic feedback, touch, spatial audio, even smells maybe. This is the simulated world where the learner physically interacts with virtual objects, tools, systems.
The stage, essentially.
Right. 2. Social environment simulation. If the training involves interacting with virtual characters, avatars, other agents, maybe team training, or customer service simulation, this component simulates those complex social dynamics. Crucial for role-playing, developing interpersonal skills. 3. Learner and tutor simulations. This is the intelligent core, where the AI really comes alive. The learner cognition simulator models the learner's cognitive state in real time. Critically, it uses not just kinetic data, where they're moving or looking, but also a rich array of non-kinetic sensing inputs. Think eye tracking data, where are they focusing, facial expressions, confused, confident, maybe even biosignal sensors, heart rate, skin conductance, suggesting stress or engagement. This gives an unprecedentedly deep, real-time read on the learner's internal state.
Wow, really trying to read their mind almost.
In a way. Then the tutor simulation operates in the innermost loop. Based on that incredibly detailed dynamic learner model, it selects from a repertoire of specifiers the ones that are most likely to elicit the intended situated conceptualizations in the current learner. These specifiers are subtle, intelligent teaching interventions, maybe a slight visual highlight on a critical valve, a guided question popping up as text, a gentle camera reorientation, all designed to subtly shape the learner's understanding and actions right then without being too heavy-handed.
So it's detecting what the learner needs to grasp and then gently nudging them towards that insight in a really precise, personalized way. How is this actually implemented? And what about scaffolding within this AI tutor?
Implementation relies heavily on cutting-edge, deep learning-based AI methods. All that extensive sensor data from the VR environment, eye face trackers, biosignal sensors can be used to train highly accurate machine learning models. These models learn to recognize specific learner cognitive states in real time. This lets the AI tutor infer moments of confusion, mastery, or a need for help. It goes way beyond simple rule-based systems. Regarding scaffolding, the author stressed it's a complex relational concept, as Roy P. noted back in 2004. It's not just about giving simple hints. The AI tutor's scaffolding wouldn't be a rigid, preset list of rules. Instead, it would dynamically map the learner's ever-changing cognitive state to the most appropriate action from its intervention toolkit. This adaptive scaffolding is crucial because it allows for multiple pathways to the targeted objective. It recognizes different learners might reach mastery differently rather than being forced down one single path. It's about providing flexible, personalized guidance that adapts precisely as the learner progresses, leading them to successful, deeper skill learning.
Moving from very practical, hard skills training to something maybe more abstract, but incredibly powerful. The role of narrative in learning. Mariana Vivitz's commentary on James Lester's work highlights narrative-centered learning as a really potent approach. What is it? Why is it considered so powerful for engaging students?
Mariana Vivitsu emphasizes that narrative-centered learning is profoundly effective because it engages students in story-based activities that are fundamentally featuring problem-solving in a way that fully integrates the story with the problem-solving. It's not just a story around a problem, the story is the problem solving and vice versa. This is incredibly powerful because, well, humans are naturally wired for stories. Putting learning inside a compelling narrative makes the educational experience far more engaging, memorable, intrinsically motivating. It turns what might be abstract concepts or dry facts into relatable, unfolding experiences that students genuinely care about. They aren't just memorizing, they're kind of living the learning.
And the prime example she uses is Crystal Island. What is this? How does it use this narrative-centered learning idea with AI?
Crystal Island is an excellent pioneering example. It's an AI-based game specifically designed for K-12 students learning science. What makes it so effective is how it seamlessly weaves believable characters and complex scientific problem-solving right into the core of its storytelling. Students are immersed in these narratives not as passive watchers, but as active protagonists. Their choices, explorations, scientific investigations directly drive the plot forward and hit the learning objectives. For instance, to solve a science mystery in the game, students might have to apply biology or chemistry principles, run virtual experiments, analyze data, making the learning deeply integrated with the story, giving it immediate relevance.
Vivitsu then talks about conventional and novel metaphors shaping these AI-enhanced learning environments. What are these metaphors? How do they describe the AI tutor's role within the story?
She discusses two key metaphors that help us grasp the AI's dynamic role here. First, tutorial dialogue. This is a conventional metaphor with deep roots going all the way back to Socratic dialogues. In this metaphor, AI acts like a conversational partner, engaging students with questions, answers, hints, guiding them through tricky topics, effectively mimicking a human tutor's back and forth. With AI, this gets new meaning because the system can dynamically adapt its dialogue based on the student's real-time responses, their knowledge state.
Okay, the AI is a smart conversational partner.
Right. The second is the drama manager. This is a novel metaphor, especially in game-based learning. This AI function is like a tutor, but specifically works within the narrative context of a game. The drama manager AI supports learning by dynamically adjusting the story's flow, maybe introducing challenges, giving subtle hints at just the right moment to keep the student engaged and ensure learning goals are met. It acts much like a director guiding a play, balancing the story flow, dramatic tension, with the underlying learning objectives, making sure the story stays compelling while still serving its educational purpose.
This brings us to a really provocative idea, the agency of technology. The source talks about how AI, digital technology, algorithms are seen not just as neutral tools, but as more than human entities that both construct and transform learning. What does that mean? And how does the intriguing brittle fish example illustrate this idea of tech having agency?
Yeah, this is a profound philosophical shift in how we see technology. The idea is technology isn't just a passive instrument we use. It actively shapes and influences outcomes, exerting a kind of agency itself. Karen Barad's 2007 brittlefish example is used beautifully to challenge the traditional human-centric view that agency only comes from conscious thought or a central brain. A brittle star, relative of the starfish, miraculously survives, avoids predators without eyes or a central brain. How? Its entire body is covered in countless tiny spherical calcite crystals that act like sophisticated microlenses. These microlenses collect and focus light directly onto its diffuse nervous system, letting the animal see and react to its world.
So its body itself acts as a distributed visual system without a central brain processing it like we normally think of sight. That's a powerful metaphor.
Yeah, exactly. This implies agency can emerge from complex, distributed interactions within a system, whether that system is biological, like the brittle star, or technological, like an AI. Therefore, AI, digital tech, algorithms, can exert agency by fundamentally changing how learning happens, what is learned, how people interact with, construct, and transform their understanding. They are active, transformative participants in the learning process, not just inert tools. They shape the possibilities, the constraints of the learning experience.
That's a fascinating, almost mind-bending way to frame the human-tech relationship in learning. And this leads to needing transdisciplinary design in narrative game design and the concept of agential cuts.
Given this understanding of technology's agency, a transdisciplinary approach becomes not just helpful, but absolutely essential for effective narrative-centered game design. This means seamlessly integrating insights, methods from diverse fields, computer science, human-computer interaction, science education, not letting them stay in separate silos. The concept of agential cuts then comes in. These are defined as dynamic forces of human and more than human entities that move, interact, and transform in time and space. In AI-enhanced learning environments like Crystal Island, the game itself, the AI systems, the complex algorithms, the human designers, teachers, students, they're all interacting in this continuous dynamic process. They co-create and transform the learning experience together in real time. Crystal Island, in this profound sense, is an example of such an agential cut, a space where human and technological agencies weave together to forge new learning pathways.
So it's a dynamic interplay where everything influences everything else, constantly reshaping the learning experience. And how does all this reshape the traditional metaphor of the student as protagonist in education?
The traditional metaphor of student as protagonist gets profound new dimensions, new possibilities in these AI-based learning environments. In a system like Crystal Island, the student truly is the central figure actively driving the narrative, making choices, solving problems that directly impact the story. The AI, acting as drama manager and intelligent tutor, opens up huge spaces for exploration, experimentation, and new roles for the student that just might not be possible in a traditional static classroom. This dynamic, responsive environment makes the ideal of student-centeredness truly believable, truly actionable. It transforms the learner from a passive receiver of information into an active explorer, a problem solver, a genuine co-creator within a dynamically responsive, narrative-rich learning world.
We've explored the incredible potential of AI personalizing learning, revolutionizing classrooms, enhancing experiential education. But as AI increasingly gets into every corner of learning, we absolutely have to confront the critical ethical challenges and proactively put safeguards in place. The book starts this crucial final section with a transnational study by Jed Wei and Henel Niemi. They found a transnational policy gap in ethical guidelines for AI learning. Expert speaker, what exactly did they find? Why is this gap worrying?
Yeah, what's quite striking, as Wei and Nimi highlight, is this crucial finding. Despite a broad global consensus on the general importance of ethical AI, you see principles from the EU, OECD, etc., there's a significant lack of literature dealing with the ethics of AI-based learning specifically. More precisely, at the policy level in countries like China and Finland, there's a distinct lack of ethical guidelines for AI in education that are separate from the more general societal guidelines for AI, which often focus on industry or business. This is concerning because it suggests education as a unique and sensitive sector often gets overlooked in specific ethical thinking within national AI strategies, maybe treated just as another application area rather than one needing its own tailored ethical frameworks.
Why is education unique here? Why shouldn't it just follow the general guidelines for industry or business? Surely AI is AI, right?
That's a really important question. And the authors make a strong case for why education is different. National AI strategies, as seen in both China and Finland, often tend to prioritize industry and business sectors. This is largely driven by focusing on international competitiveness, economic growth. The implicit assumption might be that educational sectors can just adopt AI tech as customers of these broader industrial developments. However, Wei and Niemi argue forcefully that education is a unique domain. It has distinct values, goals, particular vulnerabilities. It involves developing children, young adults, impacting their fundamental rights, their agency, their future prospects. Therefore, educational sectors shouldn't just be passive customers. They should maintain relative independence or even lead the change in AI, demanding ethical guidelines specifically tailored to learning environments, explicitly addressing the unique needs and vulnerabilities of students and teachers. These ethical concerns are fundamentally different from those in, say, manufacturing or finance.
So even if specific ethical guidelines are missing, what are some key ethical themes that did emerge from their transnational policy analysis about AI and learning?
Their analysis, despite that policy gap, revealed 5 critical themes that national policies generally touch on regarding AI's impact on learning. 1. The huge potential for AI to profoundly reshape basic education, improve overall school quality. 2. The growing importance of AI in preparing the future workforce, its big impact on employment. 4. The crucial link between AI and broader human development, and importantly, student well-being. 4. The necessity of boosting teachers' AI literacy in an increasingly digital education world. And 5. AI's potential role in driving lifelong learning reform in society, ensuring people can adapt throughout their careers.
These all sound like positive potentials. But what are the more urgent ethical concerns explicitly linked to AI and education, highlighted by the authors, which these policies might not yet fully tackle?
Right. While the potential for good is great, the ethical worries are significant and urgent. The authors point to concerns like biases in algorithms. AI systems learn from data. If that training data reflects existing societal biases, racial, gender, socioeconomic, the AI will not only repeat but often amplify those biases. This can lead to discriminatory outcomes in schools, potentially affecting who gets into advanced programs, who gets flagged for help, even how fair tests are.
A huge issue.
Huge. Then, privacy and data ownership. Massive amounts of sensitive student data are collected: learning patterns, behaviors, emotional states, personal info. Who owns this data? How is it stored, protected, used? The risk of misuse, unauthorized sharing, data breaches is substantial, raises profound questions about digital guardianship of minors.
And the black box problem.
Yes, transparency and the lack of explainability. Many advanced AI systems, especially deep learning models, work like black boxes. Even their creators find it hard to understand why they make certain recommendations or decisions. This black box nature makes accountability incredibly tricky. If an AI suggests a learning path or flags a student, educators and parents need to understand the reasoning. Without explainability, trust just disappears.
Makes sense. And the last one was quite philosophical.
And a truly profound concept, a personal right to boredom. This raises a critical point about too much personalization. If AI curates every single learning experience to be perfectly engaging or optimized based on past data, it might accidentally limit a student's exposure to new ideas, challenging concepts that don't immediately click, or even the productive struggle that comes from navigating uncertainty or exploring without a clear goal. It could stifle intellectual curiosity, restrict serendipitous discovery, potentially narrow a student's intellectual horizons, effectively eliminating that space for self-directed thought and innovation that often comes from unstructured moments.
That personal right to boredom is a really thought-provoking concern. Preserving human agency, the unexpected benefits of just thinking. Now, let's explore the industry-school divide and the different ethical viewpoints between edtech companies and schools, as analyzed by Päivi Kuusa and Hannele Niemi. What are the conflicting views, the priorities creating this divide?
What's particularly illuminating here is the inherent tension that comes from the different priorities of these two key groups. For companies making AI educational tools, their ethical challenges often relate to broader issues like regulations, equality and accessibility, machine learning, and society. They might worry about overly restrictive government rules, stifling innovation, or the technical headaches of ensuring their product works for diverse users, learners with disabilities. However, there are also legitimate fears, as Kath pointed out in 2018, that companies might accidentally or even deliberately get too involved in drafting laws that mainly serve their own commercial interests, their market advantage, rather than the broader good of education.
And what are the schools worried about? Their concerns sound much more immediate, practical, right?
Exactly. From the school's perspective, the critical questions are far more practical, directly impacting their daily work and their students. They're asking, who has the power to decide which educational services the school can use? That speaks to their autonomy, pedagogical control. Then, the massive question of liability, accountability. Who is responsible for the ethical issues of those services? For example, student privacy, a huge concern given how sensitive student data is. And finally, how to ensure that AI-based services and tools are equally accessible to all and genuinely useful. This gets at fundamental issues of equity, true pedagogical value. Schools are deeply concerned about the real-world, daily impact on their students and teachers.
So it really isn't just what the technology does, but how it's actually used in the classroom. The Naji's 2019 point seems very relevant here. Ethical conflicts in schools have more to do with how the technology is used than in the technology itself.
That's a crucial distinction. It grounds the discussion. Nanaja's argument highlights that AI tools are fundamentally just instruments. The ethical conflicts, the dilemmas, they arise not from some inherent evil in the tech itself, but from the practices, the policies, the human decisions, the contexts around its use in a school.
Wow.
Tools should never be blindly trusted or allowed to guide school activities without critical considerations. This means educators, school leaders, policymakers can't just outsource ethical responsibility to the tech providers. They have to exercise critical judgment, demand transparency, hold providers accountable. It's about proactive, informed stewardship.
This clearly points to needing some essential, universally understood principles and, crucially, an ongoing conversation between everyone involved.
Precisely. The source repeats the urgent need for education and guidelines which can be implemented during their daily work by everyone. It stresses key principles for trustworthy AI, broadly identified by Jobin et al., 2019, essential for education, transparency, including explainability, making clear why an AI did something, shining light into the black box, but also understandability so even non-tech users can grasp how it works.
Okay, transparency.
Justice and fairness. Ensuring equitable outcomes for all students, actively avoiding algorithmic bias that could disadvantage certain groups. Non-maleficence. The basic ethical rule of do no harm must be rigorously applied to AI systems in education. Responsibility. Clear accountability must be set up for AI's actions and impacts, ensuring there are human decision makers who can be held responsible. And privacy. Protecting the highly sensitive personal and learning data of students is paramount. Ultimately, the author stressed that a continuing dialogue between producers and consumers, between edtech companies and schools, is absolutely essential for ethically sustainable action. This means ongoing collaboration, continuous feedback loops, a shared understanding of both the potential and the pitfalls to make sure AI serves education ethically and effectively.
That brings us to a truly innovative, almost mind-bending thought experiment tackling these issues head-on. AI ethics as a Rawlsian massively multiplayer game. What's the core problem Benjamin Alton Cowley and colleagues are trying to tackle with this conceptual framework?
The core problem they're tackling is fundamental in responsibly deploying AI for education. The twin challenges of ensuring transparency and fairness in systems that are often opaque, complex. This includes the well-known challenges of explainable AI, often called XAI, where it's incredibly hard to understand why an AI made a certain decision or recommendation. It also includes crucial issues of distributive justice, ensuring the benefits, and critically, the burdens or risks of AI are spread equitably, especially in schools where existing gaps in resources or opportunity could be made worse. They're looking for a way to test these ethical questions systematically.
And they're connecting this to John Rawls' profound theory of justice. Can you briefly explain Rawls' theory? Especially the Rawlsian justice game and the veil of ignorance idea for those of us maybe not up on political philosophy.
Absolutely. John Rawls, a hugely influential philosopher, proposed a theory of justice, saying society's resources should be distributed to maximize the benefits to the members who start with minimal resources, a principle called maximum distribution. To imagine how truly fair principles might be chosen, Rawls introduced the thought experiment of the veil of ignorance. Imagine people choosing the rules for their society's resource distribution without knowing their own status, talents, social position, or even personal biases within that society. Rawls argued that from behind this veil, people would rationally choose a maximum distribution, prioritizing the well-being of the least advantaged, precisely because they wouldn't know if they would end up in that less fortunate group. It's a way to force impartiality.
So if you don't know who you'll be, you'd choose the fairest system possible, just in case you're at the bottom. Powerful idea. How do they then adapt this into an AI-ed MMOG simulation? An MMOG is like World of Warcraft, right? A massively multiplayer online game.
Precisely. They propose this incredibly innovative conceptual framework, an MMOG, massively multiplayer online game, simulation specifically designed to study and test AI-ed deployment solutions. In this simulation, the roles of players representing teachers, learners, even AI agents are flexible and mutable. Their roles can shift between teaching and learning within the game. The game environment itself provides a controlled, authenticated flow of data, creating a safe, rigorous lab for testing different AI-ed strategies, exploring complex ethical dilemmas without impacting real students. It's like a sandbox for AI ethics.
That's a fascinating, almost futuristic way to approach ethical testing. How do they actually model player behavior in this game to make it realistic but still manage it? So what are skill atoms and behavelets?
To create predictable yet nuanced player behavior models, they use a hierarchical approach. Skill atoms are the most basic level. Think of them as the fundamental building blocks of interaction in the game. Each skill atom is a specific single game action that changes the game state and gives immediate feedback, like clicking a button, moving a piece. Building on this, they introduce behavelets. These are short sequences of these skill atoms. A behavelet represents a specific playing style or personality trait like an aggressive approach, a cautious exploration strategy, a collaborative tendency. And even further, B-chains are longer sequences of behavelets, capturing more complex, sustained behavioral patterns in the game.
So it's a way of breaking down complex human or AI behavior into analyzable, predictable units, even profiling different player styles. What are the key benefits of this fancy modeling for studying AI ethics?
The benefits are significant, multifaceted. First, this modeling offers efficiency. It dramatically reduces the complexity of raw gameplay data. Instead of analyzing every single click and keystroke, they analyze these higher-level skill atoms and behavelets. Second, it enhances privacy. It obscures exact individual behaviors while still allowing robust profiling of general playing styles. Third, and critically, it enables detailed profiling of human player data. This gives crucial insights into how AI agents might behave in similar scenarios. Crucially, because both humans and AI agents interact via the same application programming interface, API, within the MMOG, insights from human players can be directly applied to AI agents. This helps tackle a fundamental XAI challenge, the equitable evaluation of human AI activity, ensuring AI behavior can be judged by the same standards, understood with the same frameworks as human behavior.
And how do they specifically apply Rawls' justice principles to this AIE context? What do things like income and endowment from Rawls map to in their educational simulation?
To rigorously adapt the Rawlsian justice game, RJG, to AI-ed, they make insightful conceptual mappings. Income, in Rawls' original theory, representing resource distribution, maps to learning in the AI-ed MO brick. This learning is measured by standardized tests or in-game performance. Endowment, traditionally representing social status, innate talents, starting position, maps to representation in the AI-ed simulation. This representation signifies how accurately or fully a student's characteristics, like learning style, background, prior knowledge, are represented in the AI's training data. This means the simulation can test how accurately a student can be assessed or supported by the AI based on the data it has on them. The ultimate goal is to simulate and evaluate how different AI deployment strategies impact learning outcomes, especially for those least advantaged in terms of data representation or those starting with fewer learning resources.
So it provides a safe, controlled environment to explore complex ethical considerations, test AI without putting real students at risk. That's a truly brilliant application of theory.
Exactly. A key benefit, as Pinot et al. Highlighted in 2020, is the MMOG simulation facilitates reproducible AI. This is critically important for ethical testing. It lets researchers run the same scenarios repeatedly, change variables systematically, observe outcomes in a controlled way virtually impossible in real classrooms. This vastly improves the rigor and safety of ethical testing compared to deploying untested AI solutions directly into real schools, where unintended biases or negative impacts could inadvertently harm students. It provides a robust ethical sandbox for innovation.
That's an incredibly innovative way to test AI, but now let's turn to something a bit more chilling. An issue perhaps less about design, more about pervasive reality. The invisible watch of forced surveillance technologies sneaking into education. RDP and colleagues critically examine how pervasive sensors, cloud computing, AI are contributing to what many now call a surveillance state, surveillance capitalism. Expert speaker, what exactly is surveillance capitalism according to Shoshana Zuboff? How does this relate specifically to education?
Surveillance capitalism, a powerful term from Harvard professor Shoshana Zuboff, describes a new economic order. It's a market-driven process where personal data is systematically collected, commodified, then sold for profit, often through complex prediction products. It's essentially the commodification of private human experience, turning it into data for behavior prediction and control. In the educational context, this means as schools rapidly adopt more digital tools, platforms, learning management systems, assessment software, vast amounts of highly sensitive student data, academic performance, behavioral patterns, even inferred emotional states, can be captured, analyzed, potentially monetized by edtech companies. This often happens without full transparency for parents or students, sometimes without explicit, informed consent. Zuboff argues this turns students into objects, data for monetization, fundamentally eroding their agency as subjects, their right to privacy.
That's a very stark framing, and P and colleagues highlight four core surveillance technologies particularly relevant to education. Let's start with location tracking. What are the specific concerns here for students in school?
Location tracking, often a default setting in many apps used by schools or that students use personally, poses significant, often unseen concerns. Many apps track users' movements without clear disclosure. Students might be completely unaware how their physical locations are monitored. This immediately raises critical questions about student awareness, their critical consciousness about digital footprints, the impacts on their personal agency, their ability to choose freely. It also affects free movement, free expression of ideas and social affiliations, and fundamentally their feeling of belonging and trust in their school. Beyond these general concerns, the authors specifically highlight acute deportation risks for undocumented students and families if this highly sensitive location data were ever shared with or misused by government agencies. It's a real-world threat.
The second technology is facial identification technology, FIT. This has been a hot-button issue in society generally. What are the major concerns as this tech potentially enters our schools, maybe for security or attendance?
Facial identification technology, using advanced neural networks to identify people from vast digital picture databases, brings major ethical and civil liberties concerns right into schools. Primary among these are significant algorithmic biases. Studies repeatedly show alarming false positives for African American and Asian faces 100 times more frequent than those of Caucasian faces. This means the technology itself can be inherently racially discriminatory, leading to misidentification, potentially unfair, negative consequences for students from marginalized groups.
That's deeply concerning.
Absolutely. There are also profound civil liberties issues seen in prominent ACLU lawsuits against companies like Clearview AI for mass data collection without consent. Schools need to deeply consider how parental and learner understanding of these systems is secured, ensure clear accountability in embedding them, especially given generational differences in how accepting younger people are of facial recognition due to social media, where it's common.
Then there's automated speech recognition, ASR, and natural language processing, NLP. Most of us interact with these daily. Alexa, Siri. What are the unique educational implications and concerns with these?
ASR and NLP are indeed pervasive voice assistants, online writing aids, language learning apps. Their educational implications are complex, far-reaching. One key question is about developmental consequences. Does fictionless access to answers, where a student just asks and gets an immediate verbal response, short-circuit the process of reflection? That reflection is vital for deep problem-solving, critical thinking, building new knowledge, as psychologist Alison Gopnik suggests. Will kids growing up as ASR natives develop different thinking pathways?
Interesting question.
Furthermore, algorithm biases are a significant concern here too. Research by Konecki et al. 2020 found racial disparities in automated speech recognition for Black and white speakers. ASR systems were significantly less accurate for Black speakers. This can lead to profound inequities in technology access for supporting human activities, particularly impacting intersectional identities, people belonging to multiple marginalized groups. Childhood speech, with its unique patterns, accents, developmental phases, also poses unique challenges for ASR accuracy, potentially leading to frustration for young learners or even subtly influencing kids' language development if they're conditioned to change how they speak to be better understood by biased systems. And even more ominously, there's the risk in less free societies of oppressive societies controlling the kinds of answers given to questions, especially those challenging authority or established narratives, chilling free inquiry.
That's a truly profound thought. AI potentially shaping not just how we speak, but what we're allowed to ask or even think. Finally, social media mining. How does analyzing user-generated content from social media impact education and student privacy?
Social media mining involves sophisticated analysis of vast amounts of user-generated content posts, likes, shares, comments to find patterns, trends, individual insights. The educational implications here revolve fundamentally around data privacy rights and the urgent need for comprehensive curricula to empower students. P and colleagues raise crucial questions about what is being learned from experiences crafting and implementing K-12 curricula on social media use, internet economics, and data privacy rights. This topic is inextricably tied to economic system design, highlighting the urgent need for robust regulation by entities like Congress to define clear ethical boundaries for how this data is collected, used, monetized, especially regarding minors. It's about empowering students to be critical consumers, responsible creators in a data-driven world, understanding the profound implications of their digital footprint.
So, given all these challenges, algorithmic bias, black boxes, pervasive surveillance, what are the urgent calls to action for the future from P and colleagues? What do we need to do?
The authors make urgent calls to action across three critical areas. Research. There is a critical, immediate need for systematic empirical investigation into just how pervasive these surveillance techs have become in schools. We need to understand their true scope, their impact on student autonomy, learning. We also need rigorous research into effective strategies to combat that widespread sense of disempowerment, that perhaps unconscious willingness to trade privacy among students. Understanding the true scope is the first step.
We need the data on the impact.
Exactly. Policy. A major gap, particularly in places like the U.S., is the lack of robust laws, regulations governing tech like facial identification technology in schools. There's an urgent need for legal protections against discriminative uses of inaccurate tech, especially for minoritized groups disproportionately affected by algorithmic biases. Policies must be proactive, not just reactive.
And practice, on the ground.
Practice. At the ground level, schools must proactively protect students' digital privacy rights. This means rigorously training all staff on responsible data sharing, building a culture of data stewardship. Crucially, they must integrate foresight on future consequences into every step of technology research and development, especially for EdTech. This demands transparency from developers, clear accountability mechanisms from the start, ensuring technology truly serves students ethically and effectively. It's not enough to just react to problems. We have to anticipate, design ethically from the very beginning. Hashtag outro.
And that brings us to the end of another deep dive. We've journeyed through the incredible, truly transformative potential of AI, how it can personalize learning in ways we maybe only dreamed of, revolutionize classrooms, really enhance experiential education through immersive games, simulations. From that fascinating idea of artificial curiosity to the promise of intelligent textbooks that actually understand you, the possibilities, well, they genuinely seem limitless.
But, as we've thoughtfully unpacked, this amazing technological advance comes hand in hand with a critical, often really complex ethical minefield. We've explored the pervasive challenges of inherent biases in algorithms, the very real threats to privacy, fundamental data ownership, the unsettling lack of explainability in AI's black boxes, even that profound philosophical idea of a personal right to boredom. All underscored by the ever-present, sometimes subtle nature of surveillance technologies integrating into our educational landscapes, creating that invisible watch.
Indeed, it's abundantly clear AI is rapidly reshaping our learning landscapes. It's no longer a question of if it will be adopted, but how it will be guided, implemented. So the provocative thought we want to leave you with, something for you to maybe mull over, explore on your own, is this. As AI becomes an undeniable, increasingly powerful force in education, how can we as individuals, educators, parents, as a society, move beyond simply adopting these powerful tools to actively and consciously design an educational future? A future where AI unequivocally amplifies human potential, fosters true equity for all learners, and steadfastly safeguards individual agency, fundamental rights, rather than accidentally diminishing them. It's not just about what AI can do technically, but what we, as thoughtful learners and citizens, demand it should do for the enduring benefit of all.
Thank you for joining us on this deep dive into AI in learning.
We'll catch you next time.